No daily check, nothing. Just gonna keep rolling through 4-2. Forgot to do this with you. Go to that front page of 4-2. We talked about what a radian is. We talked about the different fractional parts of it. Said the big idea behind it was a radian is a radius. We're going to need that today for unit conversions. But probably be pretty handy next to all of our standard degree measurements to have the radian equivalents. So you think of it in terms of fractions. Come on, Frank, wake up. If I cut the circle in half, 180 is equivalent to how much? Radians. Pi. That was our conversion factor. So whenever we break this up, we're looking at effectively not portion of a circle, we're looking at portion of a semicircle. Okay, how much of the calzone instead of the pizza? So if this much is pi, then keep going. The full circle is 2 pi. And if I were to cut that in half, then what? 90 degrees would be half of a pi. So I'll mark this as pi over 2. This is 2 pi over 2. It's just already reduced. So what is 270? 3 pi over 2. I don't wanna. Hey? Yes? Okay. Yep. Lammer's looking for you. Some form. If I then cut that in half. Half of a half is a quarter. So that means all of my 45 degree marks are going to be by quarters. You just have to be able to count by fractions. So you have 1/4 pi, 2/4 of pi, so half. 3 pi over 4, 4 pi over 4. Where's the next one and what is it? 5 pi over 4 at 225. 6 pi over 4 is at 270, already there and reduced. 7 pi over 4 at 315. If I were to instead cut up by thirds or sixths, I think it'll be easier to just go by sixths. What fraction of pi is 30 degrees? What fraction of the semicircle? Right, 1/6. Because I take 180 divided by 30. It's 1/6 of the way there. So every one of my 30 degree increments is going to be counting by 1/6. So I'll have 1/6 pi. 2 pi over 6, reduce it. 3 pi over 6, already there and reduced. 4 pi over 6, reduce it. 5 pi over 6. 6 pi over 6, already there and reduced. You finish off the bottom. Are all 3 of them gone at track? Okay. I thought so, but it's not in campus yet. Okay, just keep counting by sixths. 6 over 6, 7 over 6, 8 over 6, reduce it. 9 over 6, they're reduced. 10 over 6, reduce it. 11 over 6. Okay, that big scary unit circle up in the corner there, this is all the measurements inside of it. This is all the blue and red stuff inside. It's just the degrees and radians of those measurements. Notice they are all in increments of 30, 60, or 45. Because those are my special right triangles, and the entire unit circle is made up of the special right triangles. Now, I can have other things on the circle. I can go find the sine value of 38 degrees. I can go mark in what quadrant I'm going to have negative 11 pi over 7. I can do that stuff. It's just these are the special ones that we got to know because they're based on the special triangles. Okay? So, everyone got those all labeled and everything? Forgot that yesterday. Okay, so we talked about the DMS system. Okay, it's kind of funny that he just walked out in the room. It's just in your calculator. Yeah. If I do 213 degrees and I go to second right above apps, it's angle. And there's the degree, the minute, the second symbols. There is also change to DMS or change to decimal. So if I had like 300 and, or I don't know, 218 degrees or point, then I would just second, go to angle, and switch it over to DMS. Well, look in your angle. I can go to degrees? Question mark? Nope. So it's a one-way conversion. It doesn't go both ways. But it's something that we got. Okay, we went through the DMS system. We talked about radians is radius, definition of radians. We did some conversions. We started talking about coterminal positive and negative angles. We left off with all coterminal angles are this plus 360n, where n is an integer, because I'll just keep adding or subtracting elements of 360. Or I'll have that same angle plus 2 pi n, or 2n pi, depending which book you're in, where n is an integer. Oof. I swear that's a z. My soul is intact. So, that's where we left off. We need to draw them. So, start with identify all angles coterminal, draw it, sketch a positive and negative coterminal angle. To make all angles coterminal with, it's super easy. I just say 45 degrees plus 360n, where n is an integer. It's going to be the same thing every time. It's just this changes. Okay? Now, what quadrant is 45 in? Okay, quadrant 1, halfway through. So I label, here is my initial angle. And I'll say it's 45 degrees. Now, If I want the negative coterminal angle, that's the easy part. I just go the other direction. My negative angle, I'll just go the opposite direction, and how far would I have moved if there's 360 total in the circle? Take 360 minus 45, I moved 315, but I have to label it as a negative 315 degrees because I went clockwise. Remember, positive, negative with angles only denotes direction. Another thing that was not covered in geometry was vectors. You did? Maybe. So like vectors can be positive and negative depending on which direction you're going. Okay, it's basically Pythagorean theorem gets you the magnitude, and then it can be positive or negative depending on whether you're pushing or pulling. Okay, very similar with our angles. My positive coterminal angle, positive means I have to rotate this way, but I can't just stop here because they're in my spot. I've already said 45. So I have to go all the way around the block and try it again. I'll add an additional 360 degrees onto that 45, getting 405 degrees. And yes, you can be that pedantic kid. If you really, really, really want to, you can say 45, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and say
so what would the possible benefit of
being pedantic? The same benefit as being pedantic in conversation is. It makes you feel smart because you need an ego boost because you have low self-esteem. This is a way that you can do it, but it's not necessary. It's overkill. Okay. If it's in pi, the only difference is we're going to be adding and subtracting 3 pi instead. So, or 3 pi, 2 pi, words, hard, tired. First, all coterminal angles. I will say negative pi over 3 plus 2 pi n, where n is an integer. Again, the only part that's changing is alpha, my initial angle. What quadrant is negative pi over 3 in? Fourth quadrant. Pi over 3 is a third of the way to pi, a third of the way from 0 to 180, and negative means I go clockwise. So my initial angle is going to be about here, and we show the rotation, we say negative pi over 3. Now, which one's going to be easier, positive or negative coterminal angle? The positive, because I don't have to lap it around, right? So I'll just go the other direction. And just like with degrees, I'd say, well, the whole thing adds up to 360. Disregard the sign. In this case, the whole thing adds up to 2 pi. Disregard the sign. So what is 2 pi's minus a third of a pi? Right? Because 2 pi is 6 pi over 3. 2 pi is 6 pi over 3. So if I have 6 pi over 3 and a pi over 3 is already there, there's 5 left. So this is 5 pi over 3. The negative coterminal angle, on the other hand, if I come this direction, oops, he's already in my spot. So I go all the way around the block and try it again. I'm going to go an additional negative 2 pi. So a negative 6 pi over 3 with a negative pi over 3 is negative 7 pi over 3. Now, you don't have to write it off to the side, but sometimes it'll help us to write negative pi over 3, negative pi over 3, to say my positive coterminal angle is plus 2 pi, is minus 2 pi for the negative one, and to just show that, I could turn that into 6 over 3, I could turn that into 6 over 3, so I got my angles of 5 pi over 3 and negative 7 pi over 3. If you need to just show it off to the side, literally this plus 2 pi, this minus 2 pi. Sometimes it helps to have it written out. Sometimes you're cool just putting it on your picture. Okay? It does say sketch, so it don't have to be an artiste rendition of these angles. As long as everyone else in the room could be able to look at it and say, yeah, I get it. Okay? So 30 and, or negative 30, and 3/4 pi, go. First, make sure that you got your angles in the right spots. A common goof on these is that kids do the basic addition and subtraction just fine, but then they draw the angle in the wrong spot. So make sure you got your angle in the right spot at least. Okay, all coterminal angles is thing plus 360n or thing plus 2 pi n, depending. Oh, don't cross the streams. Don't have angle in radians and then write plus 360N, right? Don't mix degrees and radians because they're different measurement systems. I could just write on here, all right, negative 30 plus 360, 330 degrees. I could say 3 pi over 4 plus 2 pi, which is 8 pi over 4. Negative 30 minus 360. And 3 pi over 4 minus 2 pi, which is 8 pi over 4, is negative 5 pi over 4. You can write them out if it helps you. It's not necessary. But my negative coterminal angle will go all the way around and hit it again. My negative coterminal angle will just be the opposite direction. My positive coterminal angle will be the opposite direction. My positive coterminal angle will have to lap around. And I will freely admit that if you don't have some sort of different colors with these, it just looks like a little hypnosis wheel in the middle of your paper. All those spirals everywhere. Nothing wrong with doing two separate ones. Like draw the negative 30 2 times. Put your positive angle, put your negative angle. Nothing wrong with that. Take up a little more space, but perfectly fine. Okay? Again, whether you write them up here or you write them here, what's that? 3, yeah, 3. Boop, boop. You don't have to show these parts. You could just show these, and that's fine. And arithmetic, it's just getting used to the numbers. What was this one? Negative 390, and this was negative 5 pi over 4. Okay. Questions about it? These okay? We okay with the spirograph thing? Some kids get mad at it. Every year there's 1 or 2 kids who this just does not click. All right, cool. On to the next. Cool. All right, arc length. We kind of talked about this the other day. Central angle measurement. Good. I'm kind of talking about this yesterday when we were doing the whole DMS system. And the question was really like, when am I going to use this? Why would I need to know this? And it's application problems involving locations and circumference of the Earth. Do you remember the formula for circumference? That's area. So the whole way across is called a what? Diameter. Or part of the way across is called the radius. Circumference, remember, radian equals radius. How many radians is the whole circle? 2 pi. So the circumference is 2 pi of the radius. Circumference is 2 pi r. Or just pi times diameter, because diameter is twice the radius. Okay? So either one of those, the question is, what if I only want part of it? What if I only go from here to here? Divide by the...
You know what I'm talking about.
I just want to get the words out there.
The words.
Okay, now you're just making stuff up and doing jazz hands at me. It's a portion. It's a portion of the circle. If I know that this is x degrees, then I have x degrees out of 360 of the entire circle. This is what you learned back in geometry. If circumference is 2 pi r, then we call it S is arc length. I don't know why. They just like using S for arc length. Is going to be 2 pi r by x out of 360. Okay. Now, what is 2 over 360? Right? 1 over 180. What is 2 pi over 360? And pi over 180 is what we multiply by to turn degrees into radians. So this is what you got in geometry. This is what you get with PreCalc. Radians times radius.
All of that just to get that?
Uh-huh.
That's so rude.
Okay, I'll prove it. Pi over 4 is how many degrees? 45. So if I took 45 degrees out of 360 times 2 pi r, well, 45 out of 360 is 1/8 times 10 pi, right? Reduce, because 90 goes into 360 4 times, so 45 goes into 360 8 times. So 1/8 times 2 by 5 is 10. 10 over 8 is 5 pi over 4. That's what you would have done in geometry. What I'm telling you now is radians times radius. 5 pi over 4. Okay? Because if you only know the shortcuts, what happens when the shortcut's gone? What happens when the shortcut's blocked? If the only thing that you know how to do to pass math class is photomath and Slater, what happens when your parents take your phone? Okay.
Son never said some of the translations.
Yeah.
That's a saying.
You can get 3 in a day. We can have food on Monday.
I want them on Monday. Do it. I think.
Okay.
It actually is a thing that there's a saying that there's a will, there's a way, right?
Yes.
I'm not just making
That is a phrase, yes.
Good.
Why should I do? Why say it?
Okay, I can either do, my arc length is 2 pi r times 60 out of 360, or
60 times 2.
what? No, that's not in radians.
Or what?
60 degrees is how many radians? How far of the way to pi is it? It's pi over 3. Okay? Or I could say the arc length is just pi over 3 times 2. Knowing radians will make these faster. Okay, so it doesn't matter which formula you use. I don't care. it's 2 pi over 3 inches. Now, if I asked you to measure out something that is 2 pi over 3 inches long, not many of us would be able to do that. So could you give me the decimal approximation for it?
Yes.
That's like, what's that, 2 by 0.4 something, 2 by 1.4, 1.5, so like 2.5-ish? 2094. This is what I'm looking for. This is what most people are going to understand. Okay? Yes. What you have to do is the expression. The expression is the actual, factual, correct answer. If you want to do the decimal approximation with it, that's cool. So, go. I would recommend, as we're getting these different measurements in both degrees and radians, that you get used to try to mentally figure out how many degrees is this radian? How many radians is this degree? Keep doing that on the problems instead of immediately going to your notes, instead of immediately going to your calculator, because you got to get familiar with them. Okay? By all means, check it, but try to figure it out first. Yep. Numerator with numerator, denominator with denominator.
So that's just it?
Yeah. Fractions and terms of pi are vastly superior. Well, they're more accurate, they're more precise. It's like, think about how many of you actually still sharpen a wooden pencil and use that in class. The efficiency of just a mechanical pencil is just superior, right? But when you're a little kid, you got the big pencil because that's what helps you to develop your grip and your writing style. Okay? How many of you used to have those big chonkers? Right? Okay? When you very when you very first start writing, it's those massive ones, right? Because you have to learn to develop that pincer grip. It's more efficient to use a normal pencil. It's more efficient to then transfer over to a mechanical pencil, and then as you become more proficient in your writing, you're less likely to make mistakes. Eventually, more people will transfer over to pens because of the permanent ink and the graphite not smearing all over the place, especially lefties. Okay? Right? Lefties, how many of you got that multicolored hand by the time you're done? Okay? Yes. This is arc length. This is how far you would travel around that arc or part of a circle. Okay, think about it like, okay, I probably shouldn't use the chain just because I might slap someone. Hopefully this doesn't fling off of there. But if you just spin something, right? If you did a slow-mo video of that and then stopped it when it was here and stopped it when it was here, right? That's arc. It's from here to here, and it's that curved distance. Now that can have a lot of applications because there's a lot of things that move in circular patterns, like wheels. Very common that we have word problems involving linear and angular speed. How about gears? How about conversion factors between one gear to another? Senior. Cadence was the only senior in here. No. Do you remember the, what's it called? Not the ASVAB, the NCRC. They love doing problems with gears on there, right? Where if this one turns this way, which direction is this one turning? Okay. Okay, now what happens when you also start doing the differentials between them, comparing this circumference to that circumference to that circumference to find out how many times this is actually spinning per minute? Now you in physics, okay? So, yes. So we've got two kinds of speed. First of all, go back to old school physical science. What is speed?
Distance and time.
Right?
Is that actually right?
Distance and time, right? Think about just your vehicle. What is the speed limit by the high school? Okay? In school zones, it's usually 10 or 15 miles an hour. Miles per hour. Distance per time. Okay? So you have two kinds of speed. You're going to have regular old velocity. Now, I don't like that they use velocity because velocity also is supposed to incorporate direction, but we're just going to roll with it. Okay? Is distance over time. The distance that we're going to talk about is the arc length. Arc length per time. And this is linear speed. Okay, it's right there. It's in this text box. I'm just writing it next to this, so we got a big circle. Okay, the other one is angular speed. And that's got that funky little W, like, you know, the apple bottom jeans going on. That's going to be rotation per time. Okay? This is rotation per time. And that is angular speed.
Is that a W or like?
Wait, rotation.
Greek. I just forgot what it's called because I've been up since 4 again.
Wait.
Angular speed, think about revolutions per minute, RPMs.
Isn't that just rotation?
No. Rotation is how far did it spin. Rotational speed is how far did it spin in a given time.
So rotation is distance.
Rotation is angle. Now, when you spin that much angle, something will travel that much distance. And this is how we're going to go back and forth between those two things. Remember that 1 radian, which is rotation, equals 1 radius, which is length. So what we're going to do is convert back and forth between them. They're going to say something like, if my vehicle is traveling 55 miles an hour and the crankshaft is this many Like they'll have a conversion factor between your tire size down to your axle, down to your words, blank, gears, thing, yeah, gearbox, up to your crankshaft. It'll have conversion factors between those to find out what your RPMs are. Think about the oldest vehicle you've seen. Does it still have that gauge? Okay, I grew up on a farm. I, running on a 1932 Alice Chalmers, and it's still got that gauge on there, RPMs. You know what? Yeah. Alice Chalmers, oh God, those things are like zombies. They'll live forever. Alice and Massey Ferguson are actually refurbished and repackaged and sent to third world countries because that can be the source of their water and power for a single village. Like, it's a big multi-billion-dollar business. Stuff that's 120 years old will happily work in a village. It's great. Like, there's documentaries on it. Watch it. Good stuff. But the only way that I'm getting through that boundary is they're going to say something like, if this is going this many revolutions per minute, what speed are they going? What linear speed are they going? So, all the way back to physical science, here's the warm-up. The easy one is, during a delivery, tires rotate at a rate of 140 revolutions per minute. If they give you something, you write it. 140 revolutions to 1 minute. Find the angular speed in radians per minute. So, I'm already in minutes. We cool. But I need to switch revolutions over to radians. Do I have a conversion factor that goes from revolutions to radians? Not 1 to 1. 1 revolution is how many radians? 1 rotation of a circle is 2 pi radians. So I'll multiply it by, which one goes where? Remember? Is it 2 pi radians over revolutions, or is it revolutions over radians? Right. 1 revolution is 2 pi radians. And I want to do that so that I can cross out revolutions. Or who was, some kids do the box. Who does the box instead? Like that. Some kids do that. They like the box. Okay. So this one's pretty easy. 140 by 2 pi is 280 pi radians. Oh, per minute. That's a different conversion factor. 1 revolution is 2 pi, 2 pi radians. 1 revolution is also 360 degrees. If you know 2 pi radians is 360 degrees, that's another conversion factor you can use. Just like, how many of you actually know off the top of your head how many yards are in a mile?
There's 5,820 feet in a mile, so
But most of us don't know directly yards to miles. Most of us would have to go miles to feet to yards. We'd have to bounce around, right? I remember it's 1760 something. I always forget what the last digit is. Okay? Okay, next one. This one got a little more juice to it. On part of the trip to the next delivery, the tire turns at a constant rate of 2.5 revolutions per second. They told me something. I should probably write it. So, 2.5 revolutions to 1 second. Find the linear speed. Notice this is angular speed. Find the linear speed in miles per hour. So I got to do revolutions over to miles. I also have to do seconds over to hours. Which do you want to do first?
Time.
Do time because I already know how? Okay. How do I turn seconds into hours?
3,000.
If you know the 3600 trick, go for it. Otherwise, you would have to say there's 60 seconds to 1 minute, and then 60 minutes to 1 hour. And curious how your physical science and early math instruction worked. What I had always done was I did seconds with seconds as 1 tick mark, minutes with minutes as double tick marks. That way I'm always knowing not just that they canceled, but where they canceled. Okay. Okay, I'm now in revolutions per hour. I don't want to be revolutions per hour. I want to be in miles per hour. The only way I'm going to get over to miles is to cross through that boundary. The boundary is 1 radian rotation is 1 radius, which is length. I have to cross through that boundary. So, do I have a way to get revolutions over to length or radians? Yeah, I know how many radians 1 revolution is, so that'll be my next one. I'll say 1 revolution is 2 pi radians. And then I'll go 1, 2, 3 tick marks here, 1, 2, 3 tick marks there. So I know that that's what it canceled out with. I'm now in radians. I'm at the portal. I am able to go from angular over to linear because 1 radian is 1 radius. Now, I'm going to put something on here that you do not need to do, but it helps some kids, is to actually write that portal down and say 1 radian is 1 radius. Some kids like writing that down. It's not necessary. Where I would say radian with radian, I am now in radii, plural of radius. I'm now in radii per hour. Now I go to, how big is the radius of that tire? 15 inches. So now I can come back out the other side and say 1 radius is 15 inches. The red was the part we don't need. What I'm saying is you can go from 2 pi radians, cross out here, and immediately go to inches. But some kids need to see the portal to walk through it. I'm now in inches per hour. I don't want to be in inches per hour. I want to be in miles per hour. So there are 12 inches to 1 foot. And there is, how many feet in a mile? 5,280 feet. You're going to pick up this ball and run every one of them. 5,280 feet to 1 mile. So my radius crossed with radius, my inches with inches, my feet with feet. If I look at the top, the only thing I have left for units is miles. If I look at the bottom, the only thing I have left is units of hours. So we now have X is 2.5 by 60 by 60 by 2 by 15 by pi. I'm leaving the pi at the end so I have the most accurate answer. A 1 by 1 by 1 by 1 by 1 by 1 by, okay, 12 by 5280. Grab calculatron. If I can get this as a fraction, I want to. So I'm going to set up fraction and say 2.5 by 60 and 60 is 3600 by 2 by 15 over 12 by 5280. Oh, come on. Come on, you can do it. You can do it. There you go. The reason I left the pi off of there is because this will get me the perfect answer. This is 375 pi over 88 miles per hour. Now, if I said that something was traveling 375 pi over 88 miles per hour, for example, if you told the cop that pulled you over, no, I was only going 375 pi over 88 miles per hour. Well, that's being pedantic. They might just write you up because. Okay? So now take that times pi. Okay? And say it's about 13.387 miles per hour. Okay? But I have the most perfect, most accurate answer there. But this is the one that most people are going to understand. So next to it, I would put, or approximately 13.387 miles an hour. So, everything on either side of that grouping, you've been doing since middle school. You beat it to death in physical science. But that right there, being able to go through that gateway of 1 radian is 1 radius, that's the new thing. If you're ever not sure about a conversion factor, look it up, right? Do you know that in the back of books, we keep knowledge? In the back of your PreCalc book, there's all of the reference pages, and it's got different conversion factors on there, okay? Google it, okay? Look stuff up. All right. One of these is the quick and easy. The other one, you got to go through that portal. Go. Milli is a prefix for 1,000, yes. Now we're really going back to physical science here. Y'all remember how to go back and forth in the metric system? What's the prefix for 10? Deca versus deci, right? What about 1,000 versus 1,000th? Kilo versus milli. Okay. Inches? Yes. Case in point, where's my stick? There we go. This is a meter stick. That is 39 and change inches. Yeah. Yes.
So I was confused on this one, so that's
Oh, if the diameter is 30, then half of that is 15, the radius.
okay. So would I have to?
Yes.
Okay.
Yep.
Thank you.
Yep, 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 yep.
I did it with the house.
Never have to say all. You say one number, and it's done.
Yes. Now, fun fact, it only lasted like 2 months. I remember a point in time, early 90s, where we tried to go metric. I remember the road signs, the speed limit signs in Grand Forks County, North Dakota, going over to kilometers and kilometers per hour. And it didn't last long because America! Everyone was so bent out of shape about it that they petitioned to change it back almost immediately.
I just think inches are so cute.
Okay. First one. Angular speed is currently 3.5 revolutions per second. I want to go over to radians per second. So this is just one conversion and done. We're going to do 1 revolution is 2 pi radians. Crossy, crossy. Getting 3.5 times 2 is 7, times pi is 7 pi radians per second. Easy peasy. Contestant 2, I got a little more to it. I'm at 3 revolutions per second. And I want to go to meters per minute. So, do we want to take care of our linear distance first or our time? Okay, get time out of there. Now, last time I did 60 seconds to a minute, 60 minutes to an hour. Are we cool with just like our DMS system going 3,600? I can say 3,600 seconds is to 1 hour. Oh! Well, darn it.
What?
Yes.
I didn't say
Yes,
nothing.
I competed to apply. You are one person. All of you.
You guys,
Equally as a
stop it. I'm a really big person.
How votes the village?
No.
They're good? Nah, get them.
Bro, village vote. I think we're good. Hey,
You don't get a vote. They don't get a vote.
we are part of the village. We are part of the village.
You're still outvoted.
No, no.
No, hold on, that's 3-3 because they abstained.
That's true, we are 3.
Yo, vote the right way.
Ollie, vote.
All right. It just means more food. Y'all good. Okay. I am now in revolutions per minute. I don't want revolutions per minute. I want meters per minute. I can only get over to meters by going through the boundary that a radian is a radius. So I have to get to radians. 1 revolution is 2 pi radians. Now last time I did not, or I wrote out the radian radius thing. I'm telling you that's not necessary if you understand that now that I'm in radians, 1 radian of angle is equal to 1 radius of length. So what is the radius of that CD? 60 millimeters. Okay, so let's see where we're at so far. We had seconds with seconds, revolution with revolution, and now we've got radians with radians. I'm now in millimeters per minute. So, last one, there are 1,000 millimeters to 1 meter. What I'll usually do is I'll switch over to squiggles. Do like 1, 2, and 3 lines, 1, 2, and 3 squiggles. I do that so that I can see exactly where it canceled. So, let's see what we got here. Pink. Yeah, pink. 1,000. Here we go. I'm going to just divide by 100, divide by 100. That'll save me some time. Divide by 2, divide by 2. 6 and 6 is 36. 36 by 3 is 144 times pi. 144 pi over 5, right? 36 by 3, no, that's 108. I'm thinking the next one, 36 by 4. 108 pi over 5. Oh, and then actually write your meters per minute. Now, again, this might be the actual accurate answer. Not many people are going to get that. So next to it, I will say, is approximately
67 meters.
Okay. If you want to think about that in terms of real life speed, 67 meters is going to be about 70 yards. I want you to think about like a CD and you roll it and it takes a minute to go 70 yards across a football field. That's still pretty fast, right? Okay. Yeah, they're really close. Meter is 39-ish inches, whereas the yard is 36. Yep, 39 and change. Inch is 2.54 or 5.8 centimeters. Ooh. Here's another type that it's just kind of expected that if you can do unit conversions, you can just figure this out, but I want to explicitly go through it. If I give you 2 different speeds, the angular and the linear, can you find the radius? Remember that we start at angular or linear and then go to the other one by going through that portal in the middle. So I will use that to take angular and linear and I will work towards radius for both of them. And then in the middle, I'll just get an equation of like 5x equals 7 and then divide. Or nastier numbers, okay? So find the rotation in revolutions per minute given angular speed, check. The radius given linear speed and rate of rotation, so that's number 14. So I'm going to start at 32 meters per second. I'm going to start at 100 revolutions per minute. I need to go find how big the radius is. So I need to work those two in towards each other because the radius was that portal in the middle. I can't compare linear and angular changes if they're not in the same amount of time. So you get to choose. Do you want this one over to minutes or that one over to seconds? I would probably want minutes because I'd get bigger numbers instead of fractions. Most kids are going to want large numbers that are whole numbers instead of fraction numbers. So I'll start over here and say there's 60 seconds to 1 minute. Shoot. Okay, cool. I'm now in minutes and minutes. Fun part about that is I can now completely ignore my denominator. Now, I'm still going to use it to get my other units out, but I'm in minutes on both sides. We're good. I'm in meters per minute and revolutions per minute. Where was the portal again? A radian is a radius. Which one of these has to move? The revolutions. Okay, this is a length distance measurement. I can leave it. I need to get that guy over to radians. So on this side, I'll take, there is 1 revolution to 2 pi radians. And go shoop. I don't need to. Remember, radian is a radius. A radius is what I'm trying to find. So I've got my equation right here. What's 32 times 60? 20. Yep. So I got 1920 meters is 200 pi radians. A radian is a radius. And since they're both happening per minute, I could just multiply both sides now by 1 minute, and that would cancel. Okay? Divide, and I'm good. My radius is 1920 meters over 200 pi. Now, I would want to simplify that, naturally. What? Speak words. 2 times 100 times pi times radius. Because radian is radius. They're the same thing. If you wanted, we could write that now. Right? Coincidental this time. It's because they chose a power of 10 over there. So, what's that? Divide by 10, divide by 10, divide by 2, 90, 95, 96, and 10, 5, and 48. So 48 over 5 pi, question mark? Be careful when you go to your calculator. That is not the answer. Why? Good old parentheses, exponents, multiplication, division, addition, subtraction. How many of you got by this in geometry? Divide by 2 pi, and your answer was about 9 times bigger than it should have been. Okay? Order of operations. Either I write it as a fraction, which has an inherent set of parentheses with it, or I have to do 48 divided by the quantity 5 pi. Okay? So just be careful when you do that.
Oh, so if they put it in fraction, it just automatically...
Because the fraction bar creates an implied set of parentheses on numerator or denominator. Yep. Okay, so I wanted to go through one of those just in case. It's a pretty common application, but neither textbook, either the old one or the new one, neither has that as an example. So I wanted to at least show that to you. We're almost there. One more formula. We did arc length was part of a circumference. So sector area, very similar. The area of a circle is pi r squared. So if I knew that this was x degrees, back in geometry, I would say, well, if I've got like 90 degrees out of 360 degrees, I know what portion of the circle I'm dealing with. So the area of a sector would just be that times x out of 360. And yet again, if I take x degrees times pi over 180, I get stuff canceling out, and you'll have the new formula, new and improved, is 1/2 radians times radius squared. Okay? Just like with arc length, going into radians will simplify things. Going into radians will also simplify sector area. Remember back in geometry, find the area of this region?
Do we have to write the little sector symbol in
Nah. That's not even an official symbol. It's just, there's no notation for that.
Is there none? Wouldn't it just be the...
There's no official,
Wouldn't it just be the... Oh, wait, no, they don't provide an angle.
right?
Or like, it's like,
I could say like area of alpha. I could do that. But I just put the pizza wedge on there so you understand. Okay? So either formula works. It depends on what you're given. Find the area of the sector of the circle. Okay? That's easy enough. Area is formula plug and chug. 1/2 radians times radius squared. So 3 squared is 9, 9 by 7 is 63, 2 by 8 is 16. 63 over 16 is very close to 4. So if I go very close to 4 times very close to 3, I'm betting my answer is somewhere close to 12. Talk to me, Goose. And we are in area now, so make sure that you're putting centimeters squared. If you don't know what the units are, you put units squared. Okay? Now, I'm doing both of these with you because I'm wondering if we forgot the donut problems.
I like donuts. No, we don't like them that much.
What if I said this was 0.9 centimeters and then told you to find that area? Okay? The targets, dartboard targets. This is usually the problem that you're dealing with in geometry, where you have like a dartboard and you want to find the probability that it hits a particular point value. And you've got to remember that it's the whole thing minus the part you don't care about. On a dartboard, you would then add in the next whole thing and subtract the part you don't care about. And you'd have to keep doing that for each ring, in addition to multiplied by whatever portion you have for sectors. Okay? But do you remember that it's the whole thing minus the part you don't care about? Same thing that worked for circles also works for sectors. Okay? So I just wanted to remind you of that because windshield wipers. So they're saying this is the area that is getting cleaned off. And they tell you that the entire wiper mechanism is 26 inches. Go! You can use either version, either the degree or radian formula, I don't care. They're just a conversion of each other. That's the part that's actually getting cleaned off the window. So you take the entire area of the sector minus the area of the sector that does not matter. Remember, the exterior angle of 130 is equal to the interior angle of 130.
Wait, what?
The central angle is also 130. Angle of the arc is 130 because the central angle is 130. It is not drawn to scale. No, by scale, that looks less than 90.
External angle all adds up to, well, maybe except circles. I don't know how that one will work.
360.
And internal ones, it's just sides plus 180.
N minus 2 times 180.
It's triangle.
Because you start at triangle and then keep adding after that.
That doesn't apply to circles, does it?
No. A circle can be found as a polygon with infinite sides. You would do end behavior, the limit of the function as n approaches infinity. If you like that idea, love trig. You derive how that area of the circle actually comes from polygons. Okay, the big arc, the entire thing covered, is 1/2 radians radius squared. The area of the smaller region I don't care about. If the wiper is 16 and the entire mechanism is 26, 1/2 13 pi over 18 by 10 squared. Here, let's get this bigger. Okay, the big sector minus the little sector. The unshaded sector needs to get out of there. Now, before you just jam that into a calculator, does anyone see the factorable part of this? What do these two expressions share?
I want to say square, but I feel like I'm going wrong.
The only thing different between them is the 26 squared and the 10 squared, right? So I could say 1/2 times this is 13 pi over 36 times 26 squared minus 10 squared, which is 400, 120, 120, 640, 676 minus 100, 576. And 576 divided by, what, 4? Yeah, 4 goes in there. So it's going to be 10, 25, 18, 19, 19, 25, 24, 44.
It's alright.
144? Oh, that's divisible by 9. This comes out clean, right? Big number pi? Yeah. Okay. Another thing that I would recommend is if you see that these both have pi in common, just jam the whole thing into your calculator without pi. Change to fraction. Now throw a pi on there. And that will give you the perfect answer every time without having to go through all the mental math and look like a buffoon rolling your eyes into your head next to the board, even though you shouldn't be doing mental math having been up since 4 a.m. So, end of 4-2. Next week, the unit circle. Okay. We did what? 1, 2, 3, 4. So, Monday will be the first half of 4-3. I think we get through the circle or right up to the circle. Tuesday will be quiz. Wednesday will be FUBAR.
Wait, Wednesday?
Because, how many juniors we got in here? Okay, we got a handful of juniors who are going to be testing Wednesday and Thursday. Sophomores are only testing Wednesday afternoon. So most of my classes are decimated on Wednesday. Unfortunately, because of the amount of time that we've lost for snow days, juniors, we're getting back to it on Thursday. You're going to have to make that one up. Okay? Yes. Who else is doing ACT this weekend? Okay. If you're more comfortable with the TI-84s, you are welcome to borrow one of those. Just please bring it back. They're expensive. What?
The rest of the package pages I didn't use. If not, I'm just.
Yeah, toss it. Or no, put it under the bat. That's recycling.
You're not recycling.